Right. Page 80, trig inverses. So trig functions have inverses. We're able to use the inverse functions to use two sides to find one of the angles, right? So normally we're using trig functions to talk about the ratio of the sides. Now we're going to be using those ratio of the sides to give us the actual angle value. So we can see in problem number one, we've got sine of theta. It equals 32 over 51. It's the same problem as yesterday, but this time we're asked to find what is theta. This problem we don't necessarily need the triangle, but I still wanted to put it on there just so you can kind of see. So let's just draw the theta on there. Just like before, we'll label the sides. The opposite is 32. The hypotenuse is 51. But that's just to get you the idea. And what this is saying, this inverse was saying we want to know exactly what that value is. And we can do that by typing sine inverse of that ratio. So now that ratio is going to output us the value. It's really that simple. We're going to use a calculator and it'll tell us what that is. You know what that means? It means we go to Desmos and we're going to click on degrees just like before. We're going to type in, click on this calculator, and we're going to look for that inverse sine. Sine to the -1. It's not talking about a power, that is the inverse sine. So we type 32 over 51. And notice that if I had not changed to radians, it would show up as 0.67. So if that's what you're getting, that's what you did wrong. So make sure you've got it in degrees. It's that simple. We use the inverse sine and it tells us that the angle is 38.8 degrees and we're done. There we go. We just found out that that little theta is 38.8 degrees. That's it. All right, so the three ways this is going to look is inverse sine, inverse cosine, inverse tangent. That's all what they mean. This is always, that x is always going to be a ratio and it gives us the angle, right? It's going to output theta, or output our angle. One other thing to notice though is that sometimes it shows up on different calculators. You can do it in Desmos too, but arc sine, arc cosine, and arc tangent mean exactly the same thing. All right, so in other words, those are equal, those are equal, those are equal. I can type either one in and I will get the same exact result. Number two, cosine of theta, again, same problem, right? Cosine of theta is 8 over 10. What is theta? You already know what to do. What do we do, right? Label just for the heck of it. Don't exactly have to. Here's theta. Here's the adjacent side. Here's the hypotenuse. How we're going to find theta? We're going to find theta by just using the inverse function. It's that simple. Or, as you know, we could now type arc cosine because those mean the same thing. That's going to give us our angle and we're going to be done. And so let's type in 8 over 10. And let's also type arc cosine of 8 over 10. And you can see that, yes, they really are the same. So 36.8. And we're done. 36.8 degrees. That's what theta is. We're done, right? Super straightforward, not tough at all. And let's keep going to problem 3. Problem 3, notice carefully what is different here. Think about this for a few seconds. What is different? So let's set this up as usual. Here's sine, here's theta. Here's the opposite side. Here's the hypotenuse. But it doesn't ask us for theta, it asks us for beta. So what are we going to do? And the answer should be the same thing as before. We're going to find inverse sine of 15 over 53, or again, arc sine of 15 over 53. And what is that going to give us? Is that going to give us beta? No, right? Beta is this angle over here. That's going to give us theta. So let's find what theta is. Found that theta is 16.4 degrees. 16.4 degrees. So what do we do now? Well, we know that theta is 16.4. We know that that is 90. And so we can calculate beta. And really, we can just do 90. Beta is 90 degrees minus 16.4 degrees. And that's going to tell us the angle that we want. So there it is. We've got our beta. Super simple. We just type these ratios in, use the inverse function. Doesn't matter if we use sine inverse or arc sine, those mean the same thing. And that's it. All right, here are the homework problems. And yep, same ideas, same exact thing. Knock them out. Let me know if you have questions. Yep, that's that simple.